In this video, we will review graphing and evaluating piecewise functions. A piecewise function is a function that actually is composed of two or more smaller functions that have certain constraints. So in this case, our function is going to be 4 minus x squared when our x values are less than or equal to 2, and it'll be x minus 3 when x is greater than 2. There are a few ways to do this problem. One of them I think is a little easier than the other, but I'll show you the second way, the harder way, and you can decide if you want to do it that way or if you want to do it the slightly easier way. That's for graphing. Before we do that, let's evaluate f of negative 1. So you'll notice we have two parts to this function. We have the part where we are less than or equal to 2, where x is less than or equal to 2, and we have the part where x is greater than 2. So when x equals negative 1, we are going to be using the upper function, the 4 minus x squared. I'm going to do it in red just so you know that it's the red function. And so we're going to plug in negative 1 for that one. When you do that, you end up getting 3. Then same thing is going to happen except with the other function when x equals 3. When x is 3, we're going to use that green function up there. We substitute in 3 for x and we get 0. Then when x equals 2, we're going to use the upper function again because that's when x is less than or equal to 2. And for that one, you are also going to get 0. Okay, so the next part we're going to do is the graph. And like I said, there's two ways to do the graph. I'm going to actually show you what you would do for the harder one. I don't usually recommend the harder way, but if you're like really good at understanding these, this way it's probably going to be a lot faster. So it's your decision how you want to do this. Okay, so here's the faster way to do it. So for the upper equation, we know that 4 minus x squared is a parabola that is upside down that has a y-intercept at 4. It looks kind of like this. We know that that's going to be our graph up until x equals 2. And we have a closed circle because it's less than or equal to. The second thing that we know is that the second part of the graph is x minus 3. That's going to happen when x is greater than 2. So x minus 3, that is actually going to look like that. We know that's actually only true for x is greater than 2, so I'm going to erase that part that I just drew and make sure that I start at the point on the graph where x equals 2. So this would be what the graph looks like. Now, a lot of people have issues with doing it this way because they wonder what's going to happen at x equals 2. So you may or may not be able to do it that way, or you can actually do a combination of the two methods I'm going to show you. So I'll show you both. So that was the first method of doing it. So I'm going to erase this and then show you the second method. So the second way I'm going to do this problem is going to be to plot points. And I'm going to start by using the first part of the equation, the part that's less than or equal to 2. So I'll make an xy chart, and this is only going to be for 4 minus x squared. And I'm going to do some negatives, I'll do some positives. That's always a good thing to do when you're doing one of these charts. So you could fill these in on your own, and you'll find that these are the values that I have. So then you're going to plot the points, and the other thing I actually forgot to draw, I always like to do a cutoff line at whatever this value is here. So I have that cutoff line. I know that everything to the left of that is going to be 4 minus x squared. So I'm just going to go ahead and plot my points. And you'll notice I do have a closed circle at x equals 2. That's because of that less than or equal to. So it's going to be a partial parabola. I'm going to do the same thing for x minus 3. So now you might say, well, let's start at 3 because we want greater than 2. We don't want equal to 2. But actually, we're going to start at x equals 2, and we're going to do a few values above that. So then you can fill in those points. And so we get these ones right here. So I know when x is 3, I have 0. And when x is 4, I have 1. So when x is 2, I have negative 1. So I'm not going to make a closed circle at negative 1. The biggest mistake I see people making on these problems is they give me something that looks like this. So that's not a full graph because between 2 and 3, there actually are parts of y equals x minus 3 on the graph. So I'm actually going to go all the way to the point 2, negative 1, and I'm going to have an open circle there.